Okay, so now we will look for the TensorFlow. So TensorFlow again is open source, managed by Google. So Google engineers, algorithm engineers, and machine learning engineers are really behind it. And in recent years, since its arrival, it's one of the most popular machine learning framework based on neural networks. Again, at the core of this neural network library is the multi-dimensional array. So if we look into TensorFlow or any other neural network based machine learning framework, we will see a multi-dimensional array ability to store and process data. So like TensorFlow has tensor in it. It also uses NumPy, which is again the n-dimensional array, multi-dimensional array library. NumPy is there, and if we look into other framework, they really use one way or other. They could use a NumPy or they use their own. Again, TensorFlow has written in Python, as well as the code is written in all C++. TensorFlow, it's also because of the support, they have TPUs at the Google data centers for processing tensors. So it supports natively for TPUs, GPUs, CPUs. So you have ability to run TensorFlow on all these variety of hardware. Interface to TensorFlow is available using R and Python. And we will also get to learn about Keras, which is a higher level API, which also give you access to TensorFlow through a very different way. So we will also look into that. I won't be really talking a lot because there are more sessions where we will go deep into TensorFlow and other libraries. So this is just to get you started. So you could go look into source code. Some of the best things about TensorFlow is actually is designed to run distributed. So it could it has ability to work on really very large data sets. That's one big thing. And second, the deployment was already thought upon when library was developed. So when the machine learning models are built and they really have to perform the scoring, and then they really need to deploy, and the deployment could be really very large, such as Google network, where they really try to support millions and millions of user worldwide. So they actually have already thought about the model deployment process. So using TensorFlow serving, they really have ability to deploy these models effectively. So TensorFlow is one good, has these 2-3 very differentiator when somebody really want to use neural network based machine learning libraries or framework. The next one is PyTorch. So PyTorch is also really very popular neural network model creation library, which also supports the GPU acceleration. The PyTorch is basically is top of it's actually designed the way the Torch neural network library was created, but the Torch was written in Lua. So PyTorch is a Python implementation of Lua basically, but it's all written in Python and C++. That's for that reason, it's Python. It's just called PyTorch. Very lightweight, comparative to a TensorFlow. Okay, and so that's why really people in some cases, if you really want to build a model, you want to create enterprise solutions for machine learning, for neural networks based machine learning, TensorFlow could be a great choice. However, if you are a researcher and you really want to put together some prototype, and there is some research paper, you want to build a research paper, and PyTorch could be something really fairly easier path in that regard. So they have their own strength, PyTorch and TensorFlow, and depending on what is your objective, you can use one or another. They both can give you a really fairly great very high accuracy. It's not like you use one for better accuracy and other. I think they are designed, their implementation is in such a way that for enterprise, for business related problems, you can actually use TensorFlow because it already has certain business related or deployment related capability built into inherently. For PyTorch, the interface is based on C++ and Python, like most of others, open source. And I would say that if you are using NLP applications, PyTorch has a lot more libraries and implementations built into, so you could actually use that for that reason as well. Some of the links are there, and if you really want to get your understanding better about PyTorch, click on these links and go ahead from there. The next library we are going to look here is mxnet. Again, it's really very popular, and before TensorFlow suddenly came into the existence, the mxnet was really very popular. And because there was Torch, and then PyTorch is also came very recently, it's not like that's very old. So mxnet was one very popular library which was really used for machine learning. And mxnet uses something called ND array, which is the n-dimensional array for storing and manipulating multidimensional data in mxnet. So it uses ND array for that reason. It also has, when we look into the interfaces, supports R, Julia, Java, Scala, Perl, Python. So you could see it's really very pop. All those interfaces really shows that it has the ability to assist variety of developers and helping them to build the machine learning neural network-based models. If you want to use mxnet with Python, it actually gives you two separate APIs. One is gluon and second is module. And recently you could also go and look into in the documentation area where there is a transformer available where you can move between gluon to module and vice versa. I really have no experience moving in between, but I have seen it, so I thought I can just let you know. I did perform some work a few months back using mxnet, and that was really very good. And even when I was in H2O, I had experience working on mxnet library. A lot more time was invested that time. But in recent years, I would say that I'm really not spending a lot more time on mxnet, so I really don't know what else is really going on there. So if you really want to know what is going on very recently, all those things, please go ahead and look into mxnet library, their documentation, and you can go from there. After mxnet, we will look into Keras. Very popular, and I would say that the most of the developers who are coming from development work, where for several years they were developing code, and now they really try to come into and understand what is a neural network, and they really want to learn understand the neural networks and start building application. They really see that Keras is something very like an easier path to come and learn the neural networks. So it's a high-level neural network API. So it's an API which really use a neural network engines underneath. So it really doesn't have all those implementation related with neural networks, but it's just to simplify to build a machine learning model building. Okay, so what it does, it supports CNN, RNN, and the combination of these two. So like a convolutional neural networks and recurrent neural networks, and you can build a model either one of them or combining them together using Keras, and then underneath you can connect with which engine you would want. So currently these four engines, TensorFlow, CNTK, Theano, and mxnet are really supported. So you have ability to choose any of them. And if you are using TensorFlow, and if your TensorFlow is really designed to run on CPU or GPU or TPU, then you could say that your code which you have created using Keras also supports GPU. So it's because the Keras does not really do processing, it really uses these engines to do a lot more processing for that reason. So if the engine is using those hardware functionality to process the code, Keras is really going to use as it is, no change at all. Very developer friendly interface. So I would say that it keeps the complexity away. So somebody who really very new to and has not too much deep concepts about neural networks, layers, and all those things, and then all various functions, they can actually learn the Keras model design, where they really start with a model which is basically, a framework to manage neural network layers. And the simplest model could be a sequential model, and then as you go further and further, it has the ability to go even more complex. And using Keras models, you can do, you can build a LSTM model. You can actually do the regression. You can do classification. You can predict the housing price, such as you are doing in any statistical model. You can also use them at the end and do the time series data processing, and then start predicting or forecasting weather or house sales price or everything. So Keras is really very powerful, I would say. And if you really are trying to venture your journey and in neural networks to build these machine learning models based on neural networks, I would say Keras is something where you can really get a lot more mileage in short amount of time. After Keras, we will look into Amazon SageMaker. I just put there for a very specific reason, because most of the packages or libraries or framework we have seen in past last 8 slides, they are all open source libraries, framework, which you can get, download, install, and run, connect with Python. Versus the Amazon SageMaker is a cloud environment which is designed to build, train, and deploy machine learning models very quickly. In this scenario, you can just pull the data into Amazon SageMaker and start processing, select few configuration parameters where you can say what kind of algorithm you really want, and if you really want to fine-tune optimization. There are so many things built into. In some way, you could say it's a automated machine learning. Yes, definitely it can be considered in so many ways. And it also has like the developer-friendly environment where you can connect the whole pipeline created within the SageMaker through a Jupyter notebook. So you could process, control, and run Amazon SageMaker through Amazon SageMaker a whole pipeline of machine learning. It's a cloud-based tool for anybody to really give it a try very quick. If you have your data set sitting in Amazon network, your lots of functionality which is really related with your business application, it sits in Amazon. I would say SageMaker could be something really very simplest way for you to perform the machine learning on the data, and then the results you could see, you have ability to apply those results in business functionality, which is available on other Amazon services. So it's a very tight integration with various services running on Amazon. So that's the reason I have put together for your, and so there is a lot more information available for about a SageMaker at Amazon documentation area. So that's one way you could really try it. The last one, or the 10th one, I have put together something called a deep learning 4J. So it stands for deep learning for Java. Library, as it's shown in its name, is written in Java, and you have the ability to access it directly using Java and Scala, and it also has ability to connect with other languages as well. It supports GPU, so so that's very a good thing, because most of these neural network libraries, in order to be relevant in this market, they have to have support for GPU, because that expedite the processing for multi-fold. So that's kind of must-have functionality for any neural network-based machine learning library or framework. As like any other neural network processing library or machine learning library, you have to have some kind of pipeline or data pipeline to handle the multi-dimensional array. For that reason, it uses a data vec, which is again n-dimensional array, which is again ND4J, so n-dimensional array for Java. So that's where it is. So I have put together for that reason is that if you are very I would say came from a Java programming background, such as me, I spend a lot more my early years writing server-side Java applications. So I really get much more familiarity with the deep learning for J. And Smile, there is another library called Smile, or I really go and look into H2O. H2O3. So these are something I can really very quickly understand what is inside code, and being open source, it's easier for me to download the code, look into the code functionality, and looking into the code, I can really understand the implementation way faster than just looking into the algorithms and research papers and see what is really written. So that's for that reason I have put several other very popular libraries such as Chainer, which is neural network library. There is another library is Cafe, which I have really not put here. There are even other statistical library machine learning libraries, or they are for R in the R. I would say within the R programming language areas that are also identity coded. So if you are interested, just let me know. I would be happy to even put together something for that reason. However, that's all I really have to talk about. We can just do a quick recap where we can say that we have talked about Scikit-learn, H2O, XGBoost, LightGBM, TensorFlow, PyTorch, mxnet, Keras, SageMaker, a deep learning for J. Hope you have enjoyed it, and I think I really enjoyed sharing this knowledge with you. And in coming presentations, I would be even talking a little more about each one of these libraries, and we are going to build some solutions around it. So once again, I appreciate your time, and thank you so much.